Okay, so in this section, we want to talk about the inverse trigonometric functions. This is another important thing. Okay, so inverse trigonometric functions. So how could we define inverse? Okay, so we usually write f to the -1. That is inverse. Yeah. So what is the most important property of inverse? AB is on the graph. Then what? You could change your x and y coordinate is on the inverse function. Yeah. So it is always what? Symmetric to the line y equal to x. This is what we learned from Collier algebra. And whenever the inverse exists, it has to be what? 1 to 1. Okay, so these are the most important things that you need to know about the inverse function. In 1 to 1 to make sure that the inverse exists. And how could you graph the inverse function? It is symmetric to y equal to x. This means x, y coordinate exchange with each other. And we write as f to the power -1. I call it f inverse. Okay. So the inverse function of f sine function. So when you look at this, okay, so what does this tell you? Is this 1 to 1? No. This sine function is not 1 to 1 because it has so many more than one thing. Yeah. So this is like when we do it in Collier algebra, we only want part of the graph to make it 1 to 1. So for here, for sine x, which part of the graph we choose? From -pi/2 to pi/2. So we only wanted what? This small part. So why do they only want this small part? I do not know. Maybe it's somebody, chose it a long time ago because it's easy, because it goes through 0, yeah. So you wanted 1 to 1 and you wanted to have everything. Okay, so this is the easiest part. Okay, this is what I guess. Okay, of course you can also choose this one if you want to, but it's not from the definition that we commonly use, but it's not wrong. It's not wrong. I can tell you it's not wrong if you wanted to choose this part. Okay. So the inverse sine function. So if we only choose that part, so what will be the domain? -pi/2 to so y equal to sine x. So the domain is what? -pi/2 to pi/2. What is the range? -1 to 1, yeah. Then similarly, what happens with y sine inverse x? Because your xy interchange, yeah. Xy interchange with y, yeah. Okay, so what happens? The domain, which will be what? -1 to 1. And the range, it will be what? -pi/2 to pi/2. So what does this tell you? Y equal to sine x. So this means what? It's a sine of x. Here is an angle which will give you a value. Okay, sine or angle will give you a value. And what else? Sine inverse. This will be the domain. It will be a value and give you a angle. Okay, so sine inverse is actually an angle. Very important. Okay, later on you will use it a lot. Okay, you will use it a lot. Okay, so graph the sine inverse function. How could we graph it? Yeah, so we can look at this picture. It's always symmetric to what? Y equal to x. So we only choose this small part of sine x, and you can make the graph, which is in blue. Okay, so the easiest thing is what? You could change, yeah? You could change the x, y coordinate. You used to have what? Pi over 2, 1. Then now it's what? X and y change. Y pi over 2, yeah? So you can easily draw the graph. Okay? And find the exact value of theta equal to what? Sine inverse x. So sine inverse of that something is always what? An angle. You guys remember. So you wanted to find an angle. Okay, so what do you need to be careful? This angle is between what? Negative pi over 2 to what? Pi over 2. It's not from anywhere, okay? From anywhere. So what does this tell you? You have to be super careful. Excuse me. With all these special values. So it typically in the exam or in the homework, these are the special values that you wanted to use. Okay, so find what sine inverse square root of 3 over 2. Okay, so let theta equal sine inverse x. So, and then theta equal to sine inverse. Yeah, so you let, I will not write this. I will directly let theta equal to sine inverse of square root of 3 over 2, yeah? So then what will be the other form? So sine inverse, what does this mean? You can always rewrite it, yeah? So that will be sine what? Theta equal to what? Square root of 3 over 2. With me? So it's like sine of theta will be what? Square root of 3 over 2. Yeah? You can rewrite it to be like this. So what is the theta? If sine theta equals square root of 2, okay, what will be the theta? Pi over 3. Okay, so theta equal to what? Pi over 3. Okay, so I will teach you guys a technique to remember this, okay? So 0, okay, so 30 degrees, which will be what? Pi over 6. 45 degrees, that will be pi over 4. 60 degrees is pi over 3. 90 degrees is pi over 2. Yeah? So here is sine theta, yeah? So what is sine of 0? 0. Sine of this is 1. Square root of 2. Square root of 3. Square root of 4. It's 1. Okay? So these are the special values that you know, yeah? Okay? So we have already learned this. Okay, so now, how could you remember this? 0 is what? Square root of 0 over 0. 2, yeah? 0 over anything. So what happened here? Square root of 1, square root of 2. What is square root of 4? 2. Over 2 is what? 1. So what will be sine theta? Square root of 0, 1, 2, 3, 4 over 2. Okay, and what will be cosine theta? It will be what? You reverse it. It will be square root of 4 over 2. What is square root of 4? 2. 2 over 2 is 1. Square root of 3 over 2. Square root of 2 over 2. Square root of 1 over 2 is 1 over 2 and then 0. So for your sine and cosine, what happened is square root of 0, 1, 2, 3, 4. And cosine, it was square root of 4 to 3 to 1, 0. But you have to remember 0, 30, 45, 60, and 90 degrees. These are the special angles. And for the tangent and the cotangent, what will you remember? Tangent is always what? Sine over cosine. If you remember all these values, you can directly divide. And the cotangent is what? cosine or sine, secant is 1 over cosine, and all these things. Okay, so this is an easier way for you guys to remember these things. Okay, perfect. Okay, so you can add similarly sine inverse. Okay, negative. So if you have a negative, what should we do? Because sine is an odd function. What happens? This negative can be what? Be front. So what does this mean? Negative sine inverse square root of 2 over 2. Square root of 2 over 2. Which one? Pi over 4. So is what? Pi over 4. Square root of 0, 1, 2, 3, 4. You can directly go. Okay. So for the inverse cosine, because cosine always start from the top and go here, yeah. Okay, so for this one, in order to choose 1 to 1, you cannot choose from negative pi over 2 to pi over 2 anymore, because that's not 1 to 1. Yeah, so then they decided to choose what? From 0 to what? Pi, this part of the graph. Okay, so what does this tell you? What does this tell you? So y equal to cosine x. For this part we choose the domain is what? 0 to pi. Range will be what? Negative 1 to 1. Yeah, so for the inverse, yeah, in order for the inverse to exist. Okay, so y equal to cosine inverse x. Okay, so this is restricted domain. Okay, so y equal to cosine inverse. Then what will be the domain? It's always the range from negative 1 to 1. The range will be what? The domain from 0 to what? Pi. Okay, so similarly we can draw the picture again. What will you do? You could change your x and y coordinate. Yeah, you could change your x and y coordinate. You can get the picture. Okay, y equal to cosine inverse x. It is a little bit like difficult than to draw than the sine inverse. Okay, so we have already go through the values of cosine too. Okay, so this part is the thing that I wanted to emphasize. Cosine inverse of negative half. Let theta equal to cosine inverse and cosine theta equal to what? Negative half. Cosine theta equal to negative half. So what will be the cosine theta equal to positive half? Do you know? So theta will be is what? It's square root of 4, 3, 2, 1. So it will be what? Pi over 3, 60 degrees, yeah. Square root of 4. And for the cosine is what? 4, 3, 2, 1, yeah. So theta equal to pi over 3. But this cosine theta equal to negative half. What happens here? Do you remember? It's always in the second quadrant, yeah? So because what is your range here? It's between 0 and what? Pi. Negative, it will be in the second quadrant. And we know this is your what? Your reference angle. Yeah? So what will be the theta we wanted here? It will be always what? In the second quadrant. Reference angle is pi over 3. Is always what? Pi minus what? Pi over 3, which will be what? 2 pi over 3. So this is your theta prime. So which will be your what? Reference. Okay, so you can you can remember all these values, or you can think about this you find the reference angle, and because cosine is what? either in the first quadrant or second quadrant because it's between 0 and pi. If it's positive, definitely it's in the first quadrant. If it's negative, it will be in the second. So always use pi. Or you can remember, if it is negative here for the cosine inverse, always use pi minus the positive angle for the angle in the positive part. Okay, so this is this one. So the inverse tangent. So what will be the inverse tangent? Of course, we only wanted to choose what? One to one, the part which we 1 to 1. For here, it's very easy. You just choose what? One period, yeah? So you just choose one period. So the restricted domain will be what? Negative pi over 2 to pi over 2. So, and the domain, what will be the range? Negative infinity to infinity. So what does this tell you? Tangent inverse x, yeah? So what will be the domain of tangent inverse x? So it's negative infinity to what? Infinity. And what will be the range? Negative pi over 2 to what? Pi over 2. Okay, so the tricky one is, what will be tangent inverse of infinity? Is what? Pi over 2. This is the tricky one. So tangent inverse of negative infinity is what? Negative pi over 2. Be careful. So infinity is there. So we wanted what? You can what? Graph, and you can choose the special values and make the graph here. So that's, you could change that x, y coordinate. You can do that. Okay, so now we wanted to follow all these things again, yeah? So for the tangent theta, you can use what? Sine and cosine, or you can remember this. But what is the most important thing? For the tangent, it's better because it's what? You can find all these things, because it's it is symmetric to origin, so you can find the negative value very easily. Okay, so tangent inverse -1, so let theta equal tangent inverse x, and theta, the thing, directly let theta equal tangent inverse -1 here, yeah? And then what will we rewrite? It will be tangent theta. If you wanted to get rid of the negative, you move to the other one. So tangent theta equal to -1. So you can forget about the negative sign for the moment, yeah? So tangent theta equal to 1, it will be what? Pi over 4. And because the symmetry, you just have what? Negative sign in front. Okay, so negative sign in front. Okay, so and then the next thing that I wanted to mention, these are the the 3 graphs, yeah? So you guys need to practice, and if you can memorize it, that will be the best. Okay, and the other thing is, you can also use what? A calculator to find the cosine inverse, yeah? And a calculator to find the cosine inverse. Okay, and so this is this thing, sine inverse, sine. So the very important thing here is you have to pay attention to the domain here. So because for the sine inverse x, in order for this to be equal, this thing has to be in the domain of sine inverse. Okay, so then this thing has to be in the what? Restricted domain of sine x. Okay, similarly, it will be what? In the domain of what? Cosine inverse. In the restricted domain of cosine. in the domain of tangent, in the restricted domain of tangent inverse, in the restricted domain of tangent here. Are you guys with me? So this you have to be super careful. Is what will be the domain? Okay, so cosine inverse 0.7. So it's in the domain from -1 to 1. So what happens here? Directly 0.7. So sine inverse sine pi. Is pi in the restricted domain -pi/2 to pi/2? No. Okay, so this means it will definitely not be equal to pi. Yeah, so because pi is not in the here. So what will we do? So it's sine inverse. What is sine over pi? 0. Yeah, so because sine of pi equal to 0, so we can write down as this as what? Equal to sine over 0. What will be sine inverse of 0? It's 0. Okay. So what will be cosine inverse of -1.2? Is -1.2 is not included, yeah? So this is what? Not even defined. Okay, so these are the tricky ones. Okay, so that's the end for this section.